The altitude, also called height, of a triangle is increasing at a rate of 1 centimeter per minute, while the area of that triangle is increasing at a rate of 2 square centimeters per minute. So you've got a triangle with the height increasing and with the area increasing. At what rate is the base of the triangle changing when the altitude is 10 centimeters and the area is 170 centimeters? Okay, again, we're going to use the 4 steps for solving any related rates problem. Identify all the rates in the problem and write them as derivatives. So we have this 1 centimeter per minute. That's the rate at which the height is increasing. So that's dH dt. It's positive 1 centimeter per minute because the quantity, the height, is increasing. If it were decreasing, it would be a negative. Okay, what's another rate in the problem? 2 centimeters squared per minute. 2 centimeters squared per minute. That's the rate at which the area is increasing. So that's dA with respect to t. And don't forget the rate that we're asked about. It's the rate at which the base of the triangle is changing. So we want to find dB dt. Okay, let's draw a picture. Since this deals with the triangle, it makes sense to draw a picture of a triangle. We don't know it's a right triangle. It's not a special triangle. It's just general triangle. We're going to let h be height. This is base. Okay, step 2. Identify the dependent variables in the derivatives and find an equation relating them. So one of the dependent variables in the derivative is one of the derivatives is h, another is a, another is b. Again, just look at the variable in the numerator of the derivative. So I have h, a, and b. So I need to find an equation that relates h, a, and b. Well, what geometric figure do these relate to? A triangle. So Google area of a triangle. Most of you probably already know that the area of a triangle, however, is 1/2 base times height. Step 3. Differentiate both sides of area equal base times height with respect to t. Neither of these quantities, area, base, or height, is constant. The area is changing over time. It's not constant. Same for the base and the height. This 1/2 is a constant, so I can use constant multiple rule. Then b times h, I need product rule. That's a product. The first times the derivative of the second plus the second times the derivative of the first. Thus now I have an equation that relates the 3 rates that are in step 1. Step 4. Take this equation, derivative of a with respect to t equal 1/2 b dh dt plus h dB dt, the equation that resulted from 3, and plug in the values that you know, and then solve the equation for what the problem asks for, which is dB dt. So we're given dA dt is 2 centimeters squared per minute. The base, we're told, Well, we don't know the base, so we'll leave it as like that for just a second. Realize my B's and my H's kind of look alike, don't they? This is an H, and the second one's a B. dH dt is 1 centimeter per minute. What's the height? 10 centimeters. And I'm going to solve for dB dt. Okay, but I need this base. Am I given the base in the problem? No, but I'm given a piece of information I haven't used yet. What have I not used yet? It's the area is 170 square centimeters. So the area is 170 square centimeters. And the height is 10. So since area is 1/2 base times height, 170 is 1/2 base times 10. So 170 equal 5 times the base. So the base is 170 over 5, which is 34 centimeters. So this base is 34 centimeters. Okay, now I've got an equation, and the unknown quantity is dB dt. So I just use algebra to solve this equation for dB dt. So I can multiply, I could distribute the 1/2. In fact, why don't I go on and do that? I was going to multiply both sides by 2, but I could distribute. Why don't I do that? So I have 17 square centimeters per minute plus 5 centimeters times dB dt. I just distributed the 1/2. Okay? So I'm solving for dB dt. Get the terms without dB dt on the left. So 2 minus 17 is negative 15 centimeters squared per minute equals 5 centimeters times dB dt. So dB dt is negative 15 over 5. Now let's get our units right. It's centimeters squared per minute divided by centimeters. So that's just going to be centimeters per minute. So that's negative 3 centimeters per minute. That's my answer to the problem. dB dt is negative 3 centimeters per minute. So what does that mean? That means that the base, at that moment in time, at which the height is 10 centimeters, the area is 170 square centimeters, the base is changing at a rate of negative 3 centimeters per minute. In other words, the base is getting smaller. So you've got this triangle, the base is getting smaller, the height is getting bigger, and the area is getting bigger.